Very good morning to all of you. Myself, Professor Mavidakar Birla from Maulana Mukhtar University Technical Campus. So in fluid mechanics, this one is your lecture number 21. In lecture number 20, unit number 2, dynamics of fluid flow or fluid dynamics, we are studying. In the previous class, we have seen the total energy line, that is TL, and hydraulic grade line. The total energy line is also called energy grade line. Okay, so we have drawn this diagram, this figure. This one is the bottom, and then the fluid upstream side, and then the hydraulic grade line and total energy line you have drawn as per the different section of the pipe flow. Okay, and what is the total energy line and hydraulic grade line? We have written that is HGL is nothing but Z plus P upon rho G, and total energy line or EGL will be P upon rho G plus V square upon 2G plus Z, that is the Bernoulli's equation, and it may be written as modified Bernoulli's equation, that is H plus V square upon 2G, and you know that H is nothing but P upon rho G plus Z. H is nothing but P upon rho G plus Z. So what that we have seen in previous class, and today we will try to solve the example on the fluid flow by using the Bernoulli's equation. An application of Bernoulli's equation, we will say today, in the form of examples. So this lecture number 21 FM, and today is I think so is 20th October 21. Okay, we will solve the example. Before that, you know that what is the velocity, what is the charge, you know the Bernoulli's equation. All this the part you already we have discussed earlier. That is the Bernoulli's equation of fluid flow is similar than P upon uh, gamma plus V1 square upon 2G plus Z1 is equal to P2 is upon gamma plus V2 square upon 2G plus Z2 plus if there is losses, head loss HL. Okay, and you know that this uh, P upon gamma is the P upon gamma is nothing but the pressure head. It is nothing but the pressure head, and V square upon 2G is nothing but kinetic energy. V square upon 2G is nothing but your kinetic energy of your flow, and you know that that is nothing but the potential head, and bottom head you can say that it is called as potential head, or sometimes it is called as atom head. Okay. Also, you know that discharge is nothing but it is called as discharge. You know, discharge is nothing but uh, called as flow rate. It is nothing but denoted by the letter capital Q, and it is nothing but what volume per second. That is the flow. Okay, this is nothing but your flow. Now, whenever you are joining there today, you will meet you are also joining. Okay, try to join on time. So this is uh, we know that the volume is nothing but Q is equal to discharge, Q is equal to velocity, velocity, velocity into area, and that is general V into A. So you know that velocity is meter in meter per second, and area is meter square. This meter is cube per second. It is also called as cubic. That is the velocity or volume. Volume meter cube is nothing. Volume per second, that is nothing but your discharge. Okay, and you know that the velocity is meter per second. And if another way you can write down the velocity, it is nothing but discharge upon area. Discharge upon area. Okay. And the head loss that is HL, it is measured as F into L by D V square upon 2G. These are the different formula. For that you should know how to calculate, and sometime HL you can calculate. It is nothing but with the hydraulic grade line or energy grade line, you can find out K1 into V1 minus V2 square upon 2G, or K2 V1 square upon 2G, or K3 V2 square upon 2G. This is the formula for HL. And you know the values of K1 and K2 and K3, how to find out at different section. K1 is equal to 1 at the entry, K2 is equal to in bracket 1 minus A1 upon A2 whole square, and K3 at the entrance of the pipe, that is A2 upon A1 minus 1 whole square. Okay, these are the formulas, and this figure already we have drawn how the levels are there: kinetic energy, potential energy, and the pressure energy, or pressure head, potential head, or kinetic energy. You can see in this diagram, this figure number 1. Okay, so based on this, we can try to solve some examples. So I will solve right of the example number 1. Example 1. Sorry. Example 1. I request all the students they should join on time so that they will not miss any point. So write down example number 1. Water flows, water flows. You should write down with, you should sit with the pen and paper and calculator, okay? Don't sit without that, and open your camera if possible. Water flows through a horizontal pipe, through a horizontal pipe of diameter 200 mm with a velocity of with a velocity of with a velocity of 20 meter per second 20 meter per second 20 meter per second. The pressure at A, the pressure, the pressure at A, A and B is, and B is, and B is given by, given by 0.25 Newton, 0.25 Newton per mm square, and 0.2 Newton per mm square. Find the head loss. Find find the head loss, head loss, head loss between point A and B, between point point A and B. So we know that this example you have to solve, and this formula first you have to write down. You know that this is the Bernoulli equation at different cross section or the flowing. Okay, you have to write down, and for this terms you know pressure head, velocity head, and potential head. Discharge is nothing but volume per second. Head loss is nothing but this HF. You know, you have to find out this value. So, what is given in the example you have to write down? We start solving this example. We start solving this example. Water flows through a horizontal pipe. Horizontal pipe is there, and diameter of pipe. So I write down D is the diameter of pipe. Is the diameter of pipe, and that is given 200 mm. It means that I will convert in meter, it is 0.2 meter, because if you convert to meter you have to divide by 1000. Okay, velocity V is also given, that is 20 meter per second, and pressure at A, pressure at A, pressure at A, it is given, that is PA is given 0.25 Newton per mm square. If I convert in Newton per meter square, then it should be multiplied by 10 raised to minus 6, 10 raised to 6. So it will be 25 to 10 raised to 4 Newton per meter square. So I have to multiply that with 10 raised to 6, and then that will be learning what is the time now. We are too late. Then pressure at B, to write down pressure at B. These all we are just writing down the given data only just now. Pressure at B is nothing but 0.2 Newton per mm square. If I will write on Newton per meter square, that is 20 Newton to 4 Newton per meter square. We have to bring all the terminology into one type of unit. Okay, mm में दिया है तो मीटर में कन्वर्ट करो, सेंटीमीटर में दिया है तो मीटर में कन्वर्ट करो, या फिर सेंटीमीटर में कन्वर्ट करो, but all the values should be in meter or in mm or in centimeter or in newton or in kilonewton. Then only you can multiply, deduct or divide. Okay, otherwise the values will be the your solution will be something wrong. So if I write down using the Bernoulli equation to solve this example, using the Bernoulli equation, so using the Bernoulli equation, pressure at A P upon rho G plus PA square upon 2G plus ZA is equal to PV upon rho G plus VB square upon 2G plus ZB plus your head loss HL. Okay, and write down in small letter capital whatever it means. So if the pipe is horizontal, the pipe is horizontal, or the flow is at the same level. It means that your ZA is equal to ZB. Okay. Also, also the pipe is uniform uniform in diameter. There is no change of the cross-section area of the pipe. It means that the velocity of flowing, it is also the same. VA is equal to VB. Okay. So what will be remain? The it will be remain PA upon rho G is equal to PB upon rho G plus HL. If I will write down HL, the head loss will be PA minus PB divided by rho G. Okay. PA minus PB divided by rho G. And you know that this PA is 25 into 10 raised to 4 minus PB is 20 into 10 raised to 4 divided by 9 point rho is for if consider water, so rho is 100 and G is 9.81. So what will be the HL after solving? To get the head loss, what is you have to find out. What is you have to find out. What is the time moving Junaid? It's too late, huh? Next time I will not allow. So I am keeping in mind also the lecture or the recording when you are joining the class, when you are leaving the class, all things are recorded. Don't think that you are the clever. Okay? So your HL will be after solving from the calculator, take the calculator. You solve this. So 5 to 10 raised to 4, 5 to 10 raised to 4, the difference between the pressure is, okay, divided by 9810. 9.81 into 1000 is 9810, you can get 5.096 meters. The loss will be 5.09 meters. This you have to find out. This is you have to find. This one is the example number 1. Let's solve example number 2. Example number 2. So here, because the pipe is horizontal, uh, okay, the velocity of flowing velocity is uniform. So in this case, your problem is very simple. Only the pressure difference will be there, and that pressure difference will be nothing but your head loss. Because VA is equal to VB, ZA is equal to ZB, because pipe is horizontal, and the flow through the pipe is having a uniform diameter. There is no change in velocity. That's why ZA is equal to ZB and VA is equal to VB. So head loss is only nothing but the pressure difference. Only the nothing but the pressure head difference. Okay. Now we solve the example number 2. Example number 2. If you consider the same pipe, the water flows through an inclined pipe. Now here there is the pipe is not horizontal. Water flows through.
सर
हाँ.
ZA और ZB क्या है?
Datum head. Datum head. ZA and ZB is the datum head or potential head. Okay. That is measured from the datum to the center line of your pipe. This figure in previous class we have drawn already.
Okay, sir.
ZA is the pressure head, potential head at section A, and ZB is the potential head at section B. Okay, if there is different section of pipes. So water flows through a inclined pipe. That's why I'm calling that you should join lecture on time and you should present in each lecture. Otherwise, you will not understand. Water flows through an inclined pipe diameter of diameter 20 centimeter 20 centimeter with a with a velocity of with a velocity of 20 meter per second. The pipe is inclined. है ना? In previous example, the pipe is horizontal. The pressure at point at each level they are same. The pipe is inclined. The pipe is inclined, inclined, and and B is B is the point B is 1 meter above 1 meter above the datum line passing through A, passing through A. The datum line is passing through A. Okay, that you have to understand. Example you have to understand. Okay, the pressure at A and B is given by the pressure at A and B. A and B is given by is given by is given by 25 Newton per centimeter square and 20 Newton per centimeter square. Okay. Respectively is the pressure. Find a head loss. Also, you have to find out the head loss between point A and B. Same type of example, but here the pipe is inclined. So what it is saying that this is a pipe and this is your point A, this is your point B, and datum is passing through A. Datum is passing through A. This is datum. So here you can say that ZA is equal to 0 because datum is positive. So ZA is equal to 0 and ZB is given and ZB is nothing but 1 meter above the datum and that datum is passing through the A. So what ZB is equal to 1 meter. Okay. Now for pipe is having a uniform diameter. Die of pipe is uniform. Okay. So that we have started a solution. Just the figure I am representing you to understand. Okay. So inclined pipe, the fluid is flowing. Okay. So here given in example the Z is equal to 0 as per the datum. ZB is equal to 1 meter as per given in the example. Pressure at A is given 25 Newton per centimeter square Pressure at P is also given 20 Newton per centimeter square. Okay, and diameter of pipe is also given, that is D, that is 20 centimeter, and velocity is also given, V is 20 meter per second. Okay, so but here you can see that the pipe diameter is same. Pipe is of uniform diameter. It means that the velocity, the flow of velocity VA is equal to V. So our equation, that using Bernoulli's equation, because velocity is same, so there is no velocity head. So that is VA upon gamma plus ZA is equal to PB upon gamma plus ZB plus your head loss HL. Okay. Now you know that the term, this one is ZA is 0. So I will write down PA. You know that 25 into 10 raised to 4 if you convert into meter, and gamma is nothing but rho g, that is 9810. Okay, I will bring this PB here, so that is PB is 20 10 raised to 4 upon 9810. So you close the bracket. I will take ZA is 0, so no need of writing that, and this is ZP upon ZB plus HF. Okay, so this pressure term I have taken one side. Okay, if you take the difference, the 5 into 10 raised to 4 is the difference in pressure, that is divided by rho g, that is 9810. To solve this, it is nothing but the previous example we have solved, that is 5.09 meter, and that is ZB is nothing but 1 meter plus HL. So if I write down HL, that is head loss, so 1 meter will become here, so 5.09 meter, 1 meter it will come here, other side it will be minus. So your value of head loss in this example, after solving, it is nothing but 4.09 meter. If the example is given, so you have to understand which type of example, draw the figure, and based on that, write down the values, unknown values, and then try to understand the example, and by using the Bernoulli's equation in dynamic of flow, you can solve the example easily. Okay. So it is small examples. You write down if multiple examples are added or conditions are added, then your example will be complicated. Your simple example you understand, then it is easy to understand the complex examples. Okay, so first of all, the basic concept you should clear yourself by reading the books and notes regularly and solve the example whatever unsolved in the textbooks, or solved example also you can try to solve, so that you can come to know how to solve or how to understand the example. So many such books are available in our library. Go through that. I will solve the example number 3. Okay. Now We will try to solve the example with different of section area so that different diameter of your pipe so that the velocity will also change. Okay. So a pipe, right now a pipe is converging converजिंग यानी उसका डायमीटर रिड्यूस हो रहा है फ्रॉम 20 सेंटीमीटर diameter at A to 15 centimeter diameter at B in a direction of flow in a direction of flow in a direction of flow. The discharge through the pipe the discharge we are generally measuring volume per second through the pipe is 0.5 meter cube per second. Meter cube per second. The pipe is inclined. Pipe is inclined at A. A is on a A is on a bottom line. A is on the bottom line. Find a pressure difference between find a pressure difference between pressure difference between find the pressure difference between A and B. A and B. Okay. For a head loss of head loss is given here 5 meter between point A and B. Between point A and B. So this problem, if you see, this problem is nothing but here the cross section of pipe is also changing and bottom is also changing, is not horizontal, and the flow is also not uniform because the pipe is converging. Velocity at A and B will be different. Okay. So we know that the formula for velocity and discharge. I will draw the figure. Your pipe is converging and its dimension is reducing. Going. This is your inclined pipe. Okay. So this is point B. This one is point A. From point A, your datum is passing. Okay. So this is your point A, and this is your point B. Okay. The cross section dimension at A is different. The cross section dimension at B is different. Okay. The cross section dimension at A is different. Cross section dimension at B is different, and the potential or datum head at the B from the datum, and because A lies on the datum, then ZA will be, we are considering 0. Okay, and Q is the discharge which is given. Q is the discharge which is given. Okay, this is this example you have to solve. So first we have to write down the given data. Given data. given data आपको लिखना पड़ेगा पहले. So diameter at A is 0.2 meter and diameter at B is 0.15 meter. Okay. Discharge is common. It is same at both places. Discharge will not change. That is 0.5 meter cube per second. And ZB is also given. ZB is given 1.5 meter. And ZA will be 0 because why ZA will be 0? Because A lies at datum. A lies on datum line. That's why Z is 0. And the head loss HL is also given, that is 5 meter. The head loss is also given. Now we know the diameter, so we can find out the area, cross section area at A. Can find out now.
सर जेड भी दिया था.
Area at
हेलो,
A, हाँ
जेड भी दिया था सर क्वेश्चन में.
हाँ, A is on a datum line and B is 1.5 meter above the datum line. If I will escape, then write down that B is 1.5 meter above datum line. I think so. I have forgotten that line. We insert that line. I will change the color. Insert that line here. Okay. The pipe is inclined at A on bottom line and insert here. B is 1.5 meter above bottom line. Sorry, I forgot this line above bottom line. So write down this. So B is 1.5 meter above bottom line. That's why ZB will be 1.5 meter. Okay. Now, because you know the diameter of the circular pipe, we can find out the area. So area at A is nothing but pi by 4 into B square. Okay. So you know the pi by 4 and diameter is 0.2 meter. We'll get area in meter square. So why I'm finding out the area at? Because you know the discharge, you can find out the velocity at A and B. Because the pipe diameter is not uniform, hence the velocity will also change. And discharge we consider that is uniform. So 0.2 square into shift of your pi divided by 4. The area at A will be 0.0314 meter square. Okay. Similarly, you have to find out area at B. Area at B, I will write down pi by 4. Diameter of at B is given 4 square. Pi by 4 into 0.15 square. The area will can calculate 0.15 square into pi divided by 4. So it is coming 0.0176 or 1767 meter square, or 0.177 you can write. Now we can find out, because you know the area and discharge. So I can write that velocity at A will be nothing but the velocity you can find out from the discharge Q upon A. So Q at A is same, because discharge will be same at A and B. So discharge is 0.5 meter cube per second divided by area 0.0314, as we have calculated. The velocity at A will you can find out. Similarly, velocity at B you can find out with the discharge Q you know. So area at B you know. So 0.5 divided by area at B is 0.0177. So you can get that. So 0.5. So that, I think so you have to calculate both the velocity, and here it is 15.92, 15.92 meter per second. So you can, because in this given example the pipe is inclined, there is a bottom head, the cross section of diameter of pipe is changing, the area is changing, there should the velocity will also change, because the diameter of pipe is not uniform, and pressure difference already we have to find out. Okay, head loss is given. Okay, now applying the Bernoulli's equation, applying applying the Bernoulli's equation, applying the Bernoulli's equation. So you know that Pa upon gamma plus Va square by 2G plus Za is equal to Pb upon gamma plus Vb square by 2G plus Zb plus head loss HL. So you have to find out the pressure head difference. So I will, the pressure value I will take one side. So Pa minus Pb divided by gamma. ये on my left side ले लिया is equal to, अब एक जैसी टर्म एक साइड दे लो, Vb square upon 2G minus Va square upon 2G, okay, plus Zb minus Za plus HL. Okay, so we have modified this Bernoulli's equation and we put the values. So Pa minus Pb upon gamma equal to Vb square, you have to write down 28.29 square minus 15.92 square divided by 2 into G, 2 into G is 9.81. Gravity acceleration plus Zb is 1.5 meter minus Z is 0 because at that term, and HL is given 5 meter. So all the things will come into the meter. solve this, uh, solve this, it will come PA minus PA minus PB upon MR into 34.38 meter. Okay, so we know that gamma is nothing but rho into G, that is rho for water, if it is water, G is 9.81 or 9810. So we can write down PA minus PG, the difference between the pressure that, that you have to find out will be 34.38 into 9810. If you multiply this, you'll get the value 34.38 into 9810 is coming is coming is coming 33726 726 7.8 Newton per meter square. This is nothing but your pressure difference between the 2 points, that is A and B, for the given example. So today we have solved the example or applications of Bernoulli equation. These examples are nothing but examples above, examples above are on application of Bernoulli equation. Example on the Bernoulli equation, you can say, not application. And then in next class we'll see the applications. This is only examples on the Bernoulli equation. And we completed three examples. Based on that, we can solve many types of example. The basic formula as given above, you shall remember. You should remember first this Bernoulli equation. Okay, so remember first this Bernoulli equation. Okay, then you know the discharge is nothing but velocity of into area, and if you have to find out the velocity, then it is discharge upon area is nothing but velocity. And as per the different conditions, total energy line and hydraulic jet line, these values are given. So the time is over now. All the examples, I think so, you have written. I will share this sheet also. So you should solve on your own. And thank you for joining. Uh, so we will stop here because you already another class. Time is